Okay, so those are your basic options for musical instruments for constructing this. Strings or pipes. If you're going to go with strings, the note that is produced by any string is just a function of the frequency of vibration. Okay, that's a lot of words. So, we know that for any wave, there's a wavelength, there's a frequency, there's a speed. V equals lambda f. Frequency is controlled by wavelength. What controls the wavelength? The length of your string. We'll talk more about tension as we go. Yeah, tension does have an effect. The length of the string, it controls the frequency that you hear. Now, we've got V equals lambda f. Nowhere in there is there a reference to the length of the string, is there? But it is length.
Yeah, it's inside.
But we don't have it in there. Length, wavelength, as though there might be some connection to the length of the string and the wavelength possible.
Yes.
Interesting.
Yeah.
Now, you might wonder about speed. Remember that the speed that you're looking at is not the speed of the vibration on the string, it's the speed of the vibrations that are created in the air. And the speed of sound in air is pretty fixed. So speed of sound in air is going to vary between about 340 meters per second and 345 meters per second. There's not a whole lot of variation in air. There is some based on temperature and humidity, but we can't really control for that. So we'll find an average velocity and go with it. Okay, where do we get our L from? Somebody said it has to do with wavelength. Remember that for any string, we can look at those first 4, 5, 10 waves possible. And we know that for the first wave possible, lambda 1 is equal to 2 times L. We can do our favorite physics thing here. Substitute in a value. We can then solve for L. So for any given note that you want to produce, any note you want to produce, you take the speed of sound in air, 2 times the frequency of that note, that will get you the length of the string you need. Pretty amazing. It's a simple calculation. It is. It really is. So you can, now we talked, you mentioned tension, yeah, and if you've ever played around with a guitar, you know if the strings are loose, it doesn't vibrate correctly, and when you tune a guitar, you tighten and loosen the strings. That's true. The strings have to be under appropriate tension in order to vibrate correctly. But when you make a note on a guitar, all you're doing is depressing the string at a fret and changing the length of the string. That's what changes the note that you hear. Okay? So you can make a stringed instrument, option 1. You can make an open piped instrument. Now, that's a picture of an open pipe. The first wave possible in an open pipe looks like that. What's different? Okay, string drawn for contrast. What's different analyze that wave perspective? What's different? Okay, so again, in a string, wave generated on a string, the ends are nodes, the center is an antinode. In a pipe, it's just the opposite. We have one node in the center, 2 antinodes. But the formula for the waves is identical. And we'll run through drawing that. Okay, so in an open pipe, this would be our first 3 harmonics. And the note that you hear is going to primarily be governed by the first. There are, and this will make more sense to the musicians than the non-musicians, or anybody who's got some musical theory. We talk about the timbre of a note, and I always say that wrong. I always want to say timbre. But we talk about the sort of quality of a note, and that's governed by the interplay of the various harmonics, the first, second, third, on and on and on. Because within a musical instrument, you start to develop interference between all those different harmonics. And so the shape of the instrument, the material the instrument is made out of, govern sort of they talk about the color of the note, the overall quality of the sound. You're not going to have a whole lot of control because you're going to be making your instruments out of probably some fairly primitive materials. That's okay. All right, now, so the note that you are playing is still governed by the length of the pipe, and it's still given by the equation V over 2L equals F. You want to calculate the length of pipe for the first harmonic, so you want to use this. That's pretty much it. We'll talk more about closed pipes a little bit later.